Okay, so here we're going to be doing it in general. So for like all x, y's, right? So it's a little bit more of a proof, but you guys are up for it. So reflexive. So what does that mean? For every x in the reals, that this is true. So what does this true mean? It means x times x, right? Because they're related to itself, is greater than or equal to 0. So x will be related to x if x times x is greater than or equal to 0. Yes, that's going to be true, right? I don't have to write a big paragraph about it. I know it's going to be true because I'm going to be taking either two positive numbers or two negative numbers multiplied times each other. It will be positive. Okay, so symmetric. So for all x, y's in the reals, so this is I want to make sure you really get this. If x, y is bigger than or equal to 0, so that's x is related to y, then y x is bigger than or equal to 0, that would be y is related to x. Is that true? Yes, it is. Oops, I'm using the wrong letter. D, right? It gave me the letter D here, so I have to be careful. So D here, okay. And that's a D there, right? Okay, so x is related to y, then y is related to x. Yeah, that's going to be true, right? It doesn't matter. You don't need to write a paragraph about that. You can see the order of operation does not matter. Okay, so transitive. So for all x, y, z in the reals, so again, this has ifs. So if x, y is greater than or equal to 0, that would be x is related to y. And if y, z is greater than or equal to 0, that would be y is related to z. Then I'll get x, z is bigger than or equal to 0. So this one's have to take a little bit of a case analysis. So case 1, if I have x is bigger than or equal to 0 and y is bigger than or equal to 0, right? That gives me x, y is bigger than or equal to 0. If they're both positive, so if that's positive, then that means that I have to have z is bigger than or equal to 0 for the yz. And so that must mean that all three of them are positive. And so yes, it will work that x will be related to the z. So check. The other case, if x's were less than 0, and the y's were less than 0, and that's how I got x, y is greater than or equal to 0, then the other, in order to have y, z is bigger than 0, if y is already negative, that must mean that z has to be negative, so less than or equal to 0, so that means both x and z are less than 0, so their product is bigger than 0. So it works. All right, I'm going to let you do this one in Zoom, and I'm going to do this one here for you. So reflexive, let's check out to see. So if 2 divides m minus n, so for every m in the integers, if I want m related to m, that means I want 2 to divide m minus m, and that means 2 divides 0, check. Okay, that's going to work. So let's go to symmetric. So to be symmetric, for every m and n in the integers, if, remember, big deal, if m is related to n, then I need to show n is related to m. Okay, so what does this mean? This means 2 divides m minus n, which that means m minus n is equal to 2k. So I need to get to n minus m. So if I multiply both sides by negative, so I get n minus m is equal to 2 times negative k. So this gives me n minus m is equal to 2l, right? Where l is equal to negative k, and that's an l is an element of the integers. What does this tell me? This tells me that n is related to m, right? So that's where I needed to get to. Started with this, did a little bit of manipulation with negative numbers to get to here. Okay, so let's do the same thing with the transitive. So remember, it's if m is related to n, and if n is related to p, then I need to get to that m is related to p. Okay, so this tells me, I want to do no arrows. I don't want you to get in the habit of arrows. I don't want to do arrows. 2 divides m minus n. So that means m minus n is equal to 2k. This here says 2 divides n minus p. So n minus p is equal to 2l. So k and l, elements of the integers. All right, now let's join these two together. M minus n plus n minus p is equal to 2k plus 2l. Look at what happens to the n's. I get m minus p is equal to, well, there you go. So let's make another letter. T is equal to k plus l. M minus m is equal to 2t. T is the element of the integers. So m is related to p. Got it. All right, so you get to do this one for fun.